You are at the Center for Art and Media here in Karlsruhe, and we firmly believe that when we talk about disruption, we have to look outside of ourselves. So many of our speakers have said that today. We have to get out of our banking bubbles, our finance bubbles, you name the bubble and there's a bubble for it. We need to look outside of ourselves. So we want to bring up artists to inspire us, to encourage us to look at things with a fresh perspective. And that's why I'm so pleased to introduce our final speaker today here, the final moment of the new Festival. He's an artist whose work we've all been enjoying here. It's on display in the Panorama Lab. If you haven't seen it, I strongly encourage you to go by and have a look. For one thing, you're already here, and it usually costs, I think, $12 to get in here, so take advantage of the fact that you're already here. Without further ado, let me welcome the artist Fabrizio Tabarini to the innovation stage, our final speaker. Thank you very much. Welcome.
Thank you. Thank you very much to have invited me. I am not properly an artist. I am a physicist, so don't be scared. But physics has some beauty. It is the beauty of nature that we try to grasp. And I will speak about electromagnetic conserved quantities. It is not a lecture about physics. Don't be scared. But I would like to show you that electromagnetic waves that has been discovered here in Karlsruhe by Heinrich Hertz. It is an important place, this, for our technology. It was used by Marconi for the radio, and we use every day with the mobile phone, for the web, etc. Electromagnetic fields are the crucial phenomenon, the crucial thing that we use for everything we have in our hands, including this laser. But, well, there is mathematical beauty. So it is like reading a score by Johann Sebastian Bach, Die Kunst der Fuge. It is 4 lines, like it is 4 lines, those equations, which are Maxwell equations. Who has the people that studied physics, etc., loves those equations. But there are also inside those equations some structures. I will be very fast on this part. Some structures of symmetries that are 10-dimensional objects, for example, included here inside, that can be used for telecommunication. Have a mathematical beauty, and you do a lot of money if you use them correctly. They can be verified by experimental physics, and then can be translated in art, as we did here. So the invariant means a property that remains everything you do to the field. So this means that I have fields everywhere, electromagnetic fields with our mobile phones, emitting here, there, etc. And the guy here is sensing all the fields to see where are the transmitting and receiving antennas to talk with the other people. And if you have a very efficient system, you have very high quality, very high download, upload of your signal, etc., etc. Those are the fundamental bricks that allow engineers and physicists to have more people connected all together. So this is invariance in time, which is energy. Invariance in space, homogeneity in space. It is what moves electrons inside the antennas and makes your mobile phone to transmit and receive. Then there are other bricks, other fundamental pillars that are the invariance of the center of energy with respect to velocities, and invariance of isotropy, of the isotropy in space, angular momentum. There are also waves that transfer orbital angular momentum. So an object like this, impinged by a strong wave, rotates, like the Earth around the Sun. And this has been experimentally proved. But why is it so important, for example, the encode N? Because the target is to connect people. So it is a lot of money. And to give you an idea, those are all the numbers that have been overtaken. So Germany paid 50.8 billion euros to use the available spectrum. So if you put more channels in the same frequencies, you get more money, essentially. That's why it is important for telecommunication. But with those invariants, if you use those bricks, like a Lego, to give you an example, you can shape electromagnetic waves, give a spatial memory to them, and then transfer much more information. So the use of these quantities increased the number of channels, which means money. This is the point of view that I don't like. Well, we all like money because money are important. But if you do physics, if you like nature, mathematics, the beauty of mathematics and physics, of course, you have to deal with this. Otherwise, you don't have fundings to do your research. And the present situation is that we have those megabytes per second of transfer, and with the new quantities, I cannot give you the details because they are in studies in progress with my collaborators around across Europe and the United States. With a suitable use of them, you can increase much more the bandwidth of any transmitted signal. But these are no words, of course, because if you start in short-medium period, you have point-to-point, Wi-Fi, near-field communication, secure communication, and other future schemes. So I was one of the pioneers of this crazy shaping electromagnetic waves to communicate and to transmit more signals. We went to Nature, which is a quite high-quality journal of physics. And we did an experiment. We communicated the idea in a different way because we wanted to have immediately a high impact. So there was a sort of a fusion between different communication. Before going to physics, I was a car race driver. So the way of thinking was different. We were looking to sponsors, private sponsors, the way of communicating, having high impact, and do things very well, like in a race team. So they gave us the Duke Palace in Piazza San Marco in Venice. So it is a very nice location. And the island in front. So everyone noticed that. And the experiment was a success. We transmitted a particular type of waves. They call them orbital angular momentum waves or fusilli-shaped waves that can help you with their spatial memory to transfer more information. So you have a natural multiplexing. It worked very well. And it was the pioneering paper that now there is a lot of literature going on. And it was fun. It was fun. It was not the usual boring experiment. We were there. There was also the daughter of Guglielmo Marconi coming there. And it was, it was totally crazy. It was with the same tension as I had here in these days. Like I remember when I was sitting in a race car and waiting for the light. And you press, so adrenaline, pure adrenaline. We did another experiment with a multinational as a partner. But then I found that working in a factory was extremely boring because I prefer to look at the beauty of nature and to have something to think differently. So we were able to triple a channel, normal channel, and have a very high data transfer rate. Other strange structures were able to transmit higher and higher multiplexing schemes. But we tried the same in ZKM during the Globale exhibition. Reality in multinational was, well, a success, study, production, etc. But what is fantastic for me is physics and nature and art. Art is a way of, in my view, showing people that we have something here inside that can be mathematics, can be your interpretation of the world, or can be an installation where you have a twisted wave impinging here in 2 receivers and transmitting 2 channels for weeks. So it worked. It worked very well. And then we prepared an installation for people. This is a mask that produces twisted waves and 2 channels in the same frequency. And the people could interact there because we have a concrete idea, experimental proof. Everything works. There is Huawei who is investing a lot of money there, and the researchers from Huawei are investing there. Oh, sorry. And we were the first who did those steps. And it was, it was crazy. Now, we go beyond that. There was a friend of mine who was a painter, Emilio Vedova, in Venice, who told me, don't stay there, look beyond. Guarda oltre, in Italian. And in fact, a series of his paintings are called Oltre, beyond. So with the collaboration here of our colleagues, Freddy Paul Grunert, Bernd Lintermann, Cristina Fiordimela, that are here, we tried to put these 4 bricks of electromagnetic waves that you can combine, use multiplexing, etc., and it is the research in physics that I'm still doing with international partners, and show people that those equations are not only beauty in mathematics, because you must train, study physics, etc., but can give you, for example, new visual ideas. And it is nice, because here you have the electric field. I come back in, I know that I couldn't do during a presentation, but I cannot resist. So electric field is important. Magnetic field, charges, and currents. So let's go there. You have the electric field, magnetic field, their mutual inclinations, because they are vectors, and it is a 10-dimensional object that I want to show you. So we cannot see 10-dimensional things. Otherwise, someone should present me his pusher, because he sells good things. But there is one way: use geometry and use those invariants. So we calculate the initial conditions. It is what you see in the panorama lab near the exit. And then you calculate the energy, the linear momentum, the set of 2 equations, the centroid of the field with respect to this point, and the angular momentum with respect to this point. They are nice to see, but it is the vision, for example, that a future Wi-Fi will have. Because if you use those invariants are things that do not vary. So you can use them as foundations for other calculation for a multiplexing, very efficient multiplexing. So you can use these spots from the fields that you sensed before and orientate your antennas or etc., etc. So if you have an idea like it was born for startuppers, first you have the idea that came out from rotating black holes, astrophysics, communication. Then you have to study, prove them, as we did in Venice, Karlsruhe, then, or look for public fundings, and then industrial partnership, or if your idea involves basic physics, and you don't know if and when you will succeed to do something and to produce something off the shelf, maybe you can go in another direction. So take a different way, think differently, and press the wrong button as I did. But in this case, I choose to make a collaboration between art, curator, and science, and communicate this idea, and doing in parallel new discoveries. Now I'm working on quantum gravity, which is different from what, not so different, but there will be something very, very nice with this sort of fusion between science and it is not a science, it is a science as art and art as a science, in my view. So there is no distinction. So concluding, and I leave you some few minutes, 1 minute and a half to be precise, to look at the installation. So there is every time you set up a project, there is a target. Idea, feasibility, application, and communicate the idea, otherwise no one will buy it. And then with the idea, you try, as said Enzo Ferrari, to infect the people with your dreams. And then you must find a new way of bringing fundings. Or you have an immediate application, or if you are a dreamer, you must find someone who believes you and develop your idea differently from the usual schemes. And I thank you for your attention.
Fabrizio Tavorini, thank you very much for your presentation. I didn't follow all of it, the gravity bit, I dropped out there, but I enjoyed all of it. And I think what he's really made a lovely point about is that at its root, technology, science, art, it's all creativity. And creativity is necessary if we are ever going to disrupt anything. I want to thank you guys for being with us here today on the innovation stage. I want to encourage you to go and have a look at Fabrizio's exhibit. It's in the panorama area, I believe. Is that correct?
Yeah.
Yeah? It's waiting for
there.
you.
You go over there. It is dark inside. And you press some light spots, and you generate different initial conditions. There are about 80,000 full numerical simulations of the field. So it was a very hard work of simulations, computer simulations. So they are not random figures, but they are results of what can happen in a landscape and what a Wi-Fi should see in the future. So it sees the fields, the invariants, calculate them, and then you optimize your signal-to-noise ratio to have more people connected.
It's not every day the artist walks you through his work in New York. You have to pay a lot of money for that. So I encourage you to take advantage of it. Go, have a look, enjoy it. Also waiting for you is a fantastic program at the Karlsruhe Schloss. We have a Lichterspiel. I hope you all know what that means. I am told it involves some kind of lights. It's going to be cool. I'm promised. There are shuttle buses waiting to take you there. Just stop by the info desk. Thank you very much, Fabrizio, and thank you to all of you for being here. Give yourselves a round of applause for sticking it out to the very end. It's been a pleasure being here with you. Enjoy the rest of the evening. Thank you.